welcome to today's lesson on measures of position. In this lesson, we will now be applying the things that you've learned from the different measures of position: quartiles, deciles, and percentiles through problem solving. So as a recall, to how many parts do quartile values divide a distribution? Very good. 4 parts. To how many parts do decile values divide a distribution? That's right, 10 parts. And to how many parts do percentile values divide a distribution? Excellent, 100 parts. So for today's lesson, here are our objectives. 1. Calculate specified measure of position for ungrouped data. 2. Solve problems involving measures of position. And 3. Perform the given task with accuracy. All right, let's start learning. For our problem number 1, Mrs. Lim gave a test to her students in statistics. The students finished their test in 35 minutes. This time is the 2.5 decile of the allotted time. What does this mean? So in problem number 1, we are asked on how to interpret measures of position, specifically decile. So for our solution, we are given 35 minutes, which corresponds to the 2.5 decile. We know that deciles divide our distribution into 10 equal parts. So each division corresponds to 10% of the distribution. Based on our illustration, 2.5 decile is located between the second and the third decile. So to interpret this, 35 minutes, which falls on the 2.5 decile, means that 25% of the students finish the test on or before 35 minutes, and the remaining 75% of the students finish the test on or before 35 minutes. And so for our answer, thus, if 35 minutes falls on 2.5 deciles, it means that 25% of the students finish the test on or before 35 minutes, and the remaining 75% of the students finish the test on or before 35 minutes. All right, let's proceed to our second problem. The scores of Miss Universe, Miss World candidates from 7 judges were recorded as follows: 8.45, 9.20, 8.56, 9.13, 8.67, 8.85, and 9.17. Find the 60th percentile or percentile 60 of the judges' scores. And what is the 35th percentile of the judges' scores? So in the second problem, we are asked to find for the unknown percentiles, percentile 60 and percentile 35. Let's start finding the 60th percentile value. So first, we arrange the values in ascending order. So we have the lowest score, 8.45, and the highest score, which is 9.20. Second step is we locate the position of percentile 60 value in the distribution using the formula for percentiles. So we have P sub k is equal to k times the quantity n plus 1 over 100. We are looking for percentile 60, that's why our k here in the given is 60, and n is equal to 7 because there are 7 scores in our data set. Now, we substitute the given to our formula, So position of percentile 60 is equal to, we replace k by 60. So we have 60 here. We replace n by 7. So we have 7. And then copy the rest in the formula. Plus 1 over 100. Plus 1 over 100. We perform the operation. So we have 7 plus 1 is 8 times 60. That gives us 480 divided by 100. That gives us 4.8. So percentile 60 value is located in the 4.8 position. Since our answer is a decimal number 4.8, we need to proceed to step 3, which is interpolation. So to perform the interpolation process, we first locate our 4.8 position based on our arranged values in step 1. So 4.8 position is between the 4th position and the 5th position. 1, 2, 3, 4. This is our 4th position and this is our 5th position. The score that corresponds to the 4th position is 8.85 and the score that corresponds to the 5th position is 9.13. Now, to get the score, which corresponds to the 4.8 position, we have to add the 4th score and the 0.8 score. So percentile 60 value is equal to 8.85 plus 0.8 times the quantity 9.13 minus 8.85. 8.85 here is our 4th score, and the expression 0.8 times the quantity 9.13 minus 8.85 is our 0.8 score. So adding the 2, 4, and 0.8, that gives us 4.8 score, which corresponds to the 4.8 position. Where did we get 0.8? 0.8 came from the decimal part of our answer in step 2. So our answer is 0.8. The decimal part is 0.8. So we use that to get the 0.8 score. 9.13 is the 5th score and 8.85 is our 4th score. So performing the operation, this gives us 8.85 plus 9.13 minus 8.85. The difference will be multiplied to 0.8. That gives us 0.224. Adding the 2, we get 9.074, or rounding that off to the nearest hundredths or 2 decimal places, we have percentile 60 value is equal to 9.07. So thus, the 60th percentile of the judges' scores is 9.07. Okay. Next, we look for percentile 35 of the judges' scores. So first step, we arrange the values. So again, our lowest score is 8.45 and our highest score is 9.20. Next, we locate the position of the 35th percentile value in our distribution using the formula. So we have our formula for percentile. We are looking for the 35th percentile. So find P sub 35. And our K will be equal to 35 since we are looking for percentile 35. N is 7 because, again, there are 7 values in our data set. We substitute our given to our formula. So we have position of percentile 35 is equal to, we replace K by 35 times the quantity, we replace N by 7, copy the rest of the formula, plus 1 over 100. Plus 1 over 100. We perform the operation. So we have 7 plus 1 is 8 times 35. That gives us 280 divided by 100. That gives us 2.8. So percentile 35 value is located in the 2.8 position. So since our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. Okay, so to perform the interpolation process, we have to locate first the 2.8th position. Okay, so 2.8 position is between the second and the third positions. Okay, so second and third positions. The score that corresponds to the second position is 8.56, and the score that corresponds to the third position is 8.67. Now, to get the score that corresponds to the 2.8 position, we have to add the second score and the 0.8 score. So percentile 35 value is equal to 8.56 plus 0.8 times the quantity 8.67 minus 8.56. 8.56 here is our second score, and the expression 0.8 times the quantity 8.67 minus 8.56 is the 0.8 score. So adding the 2 plus 0.8, that gives us 2.8 score, which corresponds to the 2.8 position. We get 2.8 here from our answer in step 2. The decimal part of our answer in step 2, we use that one to get the 0.8 score. 8.67 is our third score and 8.56 is our second score. Okay, performing the operation, we have 8.56 plus, if we perform the operations in here, the result will be 0.088. Adding the 2, that gives us 8.648. Rounding that off to the nearest hundreds or 2 decimal places, we get an answer which is 8.65. So thus, the 35th percentile of the judges' scores is 8.65. Okay, so let's now move to problem number 3. So given 30 enumeration and multiple choice items in their summative test in mathematics. So find the 75th percentile or percentile 75 of the following test scores of 15 students from grade 10A. 23, 10, 13, 13, 20, 13, 11, 17, 18, 14, 21, 15, 21, 16, and 15. And then, how many students passed the exam? So first, we find for the value of the 75th percentile. So we arrange the scores in ascending order. Our lowest score is 10, and our highest score out of 30 is 23. So second step, we use the formula for percentile to locate the position of percentile 75 value in the distribution. So we have here percentile formula, and we are looking for percentile 75. Thus, for our given k is equal to 75 and n is equal to 15, because there are 15 scores in our data set. Okay, so we now substitute the given to our formula. So position of percentile 75 is equal to, we replace k here by 75, we replace n by 15. That's it. And then we copy all the rest in the formula, plus 1 over 100 plus 1 over 100. We perform the operation, so we have 15 plus 1 is 16 times 75, that's 1,200 divided by 100, that gives us 12. So the position of percentile 75 value is in the 12th position. So since our answer after using the formula is a whole number, we don't need to proceed to step 3, which is interpolation. We directly locate our percentile 75 value in the arranged values in step 1. Okay, so thus, percentile 75 value is 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the 12th position, and the value that corresponds to the 12th position is 20. So percentile 75 value is equal to 20. Okay. Now, we will determine the number of students who pass the exam. So to find the number of students who pass the exam, we have to first determine the passing score. So we normally compute for the passing score as the 75% of the perfect score, unless other criteria are specified. So our perfect score is 30 points. So to compute for the passing score, we multiply 75% or the decimal 0.75 to our perfect score, which is 30. Okay. So to get the passing score, we multiply 75% or 0.75 times the perfect score. So in this case, the perfect score is 30. That gives us 22.5. So for a student to pass the exam, he or she must have a score of at least 22.5. Okay, these are the scores of the students. So thus, among the test takers, only one student passed the exam. Okay, a student who got the score 23. Given the scores, this implies that the exam is very difficult because among the students who took the exam, only one student passed. Okay, so that ends our solution for problem number 3. Let's try problem number 4. These are the scores of 15 students in a 40-item math quiz. 15, 35, 38, 32, 35, 28, 35, 33, 19, 30, 28, 35, 28, 29, 30, and 31. If the passing score is the third quartile, how many students pass the test? And what is the percentage of quiz takers who pass the test? Okay, so first, let's accomplish the task. If the passing score is the third quartile, how many students pass the test? So for the first task, we have to find the passing score. It is the third quartile of a 40-item quiz. Okay, and the third quartile of a 40-item quiz is 30. Okay, 30. So if we arrange the scores of the students, we have 15, 19, 28, 28, 29, 30, 30, 31, 32, 33, 35, 35, 35, 35, and 38. A student passed the test if his or her score is at least 30. So a student must get a score of 30 and above for him or her to pass the test. Therefore, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 students who passed the test because they scored 30 and above. Okay? Therefore, there are 10 students who passed the test because they scored 30 and above. For the second task, what is the percentage of quiz takers who pass the test? We know that there are 10 students who pass the test. So, to get the percentage of quiz takers who pass the test, we have to divide the number of students who pass the test over the total number of takers of that test times 100. So our answer is 66.67%. Therefore, the percentage of quiz takers who pass the test is 66.67%. We are done with problem number 4. And for the last problem for this lesson, first grading grades in math of selected grade 10 students are the following: 75, 76, 78, 80, 81, 81, 84, 85, 88, 89, and 89. What is the percentile rank of 88? And what is the percentile 50 value of the given data? This time, we are presented with a different scenario. We are given the percentile value and, let's say in this case, 88. And this time, we will look for its percentile rank. All right, let's begin. Let's first find the percentile rank of 88. So first, we have to arrange the data in increasing order. So we have here 75, 76, 78. Okay, so our data is already arranged. We just simply copy it. Okay, second step, we locate the position of 88 value. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's located in the 9th position. After that, we use the formula of percentiles to find for the percentile rank of 88. So we will just have a small twist in our formula. So in here, we are given the position of our unknown percentile, which is 9. This is what we actually solve, what we commonly solve, position of our percentile value. But then this time, it's given. And we are going to look for the percentile rank of a given score. So we have here the position of our percentile is at 9th position. And our n is equal to 11 because there are 11 values in our data set. We are looking for the rank or the location, or I mean the percentile rank of our 88 value. Okay, so this is our formula. And we substitute our given to our formula. So position of our unknown percentile rank is 9. Okay. Our k is unknown. We are looking for k. That's our unknown. And we have here our n, which is 11. Then copy the rest in the formula. Plus 1 over 100. Plus 1 over 100. We do the cross multiplication. You multiply 9 by 100. That gives us 900. And then we also multiply k times the quantity 11 plus 1 by 1 because 9 is a whole number, its denominator is always 1. So 1 times k times the quantity 11 plus 1, that gives us 11 plus 1 is 12 times k is 12k times 1 is still 12k. So dividing both sides of the equation by 12, k is therefore equal to 75. So therefore, the percentile rank of 88 value is 75. Or the other way of saying it is percentile 75 value is equal to 88. Okay? And for the next task, what is the percentile 50 value of the given data? So, of course, first step is we have to arrange our values in increasing order. And then we use the formula for percentiles to determine the location of our unknown percentile, to determine the location of our percentile 50 value. Okay, this is our formula for percentile. We are looking for percentile 50. Okay, so therefore k is equal to 50 and n is equal to 11 because there are 11 values in our data set. So position of percentile 50 is unknown. It is equal to k is 50, n is 11, plus 1 over 100. We perform the operation. 11 plus 1 is 12 times 50. That gives us 600. Divided by 100, that gives us 6. So, the position of percentile 50 value is in the 6th position. So percentile 50 is located in the 6th position. So we go back to our arranged values in step 1, 75, 76, 78, 80, 81, 81, 84, 85, 88, 89, 89. The 6th position is 1, 2, 3, 4, 5, 6 here. So our percentile 50 value is equal to 81. Okay, percentile 50 value is equal to 81. And it is also the middle value of our given data set. All right, so that ends our lesson on measures of position. So to recap, there are 3 common measures of position. We have quartiles, deciles, and percentiles. Quartiles are again the points that divide the rank data into 4 equal parts. Deciles are the 9 score points, which divide the distribution into 10 equal parts. And percentiles are the 99 score points, which divide a distribution into 100 equal parts. So we follow steps in finding for the unknown quartiles, deciles, and percentiles. First, we arrange values in ascending order or from least to greatest. Second, we use the formula to locate the unknown quartiles, deciles, percentiles. And these are the formulas that we use, okay, in finding for the unknown quartile, decile, and percentile value. If our answer here, by using this formula, is a whole number, we don't need to proceed to step 3. But if our answer, after using these formulas, is a decimal number, we have to proceed to step 3, which is the interpolation. Also, don't forget the interrelatedness of the different measures of position. All right, this ends our session for today, everyone. Hope you've learned something from our today's lesson. Thank you so much for watching. See you next time. Have a great day ahead.